Okay, welcome back to Calculus 2 and good evening. So here we're going to be talking about, let's see, which problem are we doing here? Well, we're going to be finding the arc length between 0 and 1 when f of x equals e to the x. Okay, we're not going to need this quite yet. Let me go ahead and set this thing up before we do that. So the thing you have to remember is that arc length is equal to the integral of, okay, so we'll go ahead and say arc length s is equal to the arc length the integral of 1 plus f prime of x squared, and then put all of this thing in here with a dx. Okay, so let's just take this apart and kind of figure it out piece by piece here. So my f prime of x, well, f of x is z to the x. So f prime of x is z to the x. This is shaping up to be a really easy integral then, right? So what we're going to do is we're going to square it. Okay, so we're going to say this is equal to e to the 2x, right? That's how squares work in exponents. And then we're going to add 1 to it. So we have 1 plus f prime of x. So we're going to go ahead and we're going to say we have 1 plus e to the 2x. Okay, and this is what we're going to push in here. Okay, well, let's see here. We have integral of the big square root of 1 plus e to the 2x dx. Now, I'm looking at this and I can't integrate this off the bat. Okay, nice, but no, I can't do that. So we're going to have to find a u substitution. So a lot of you guys, you're always assuming like, well, I must pick the right u every time. Like, let's try this one. And du is equal to e to the x. Do I have an e to the x on the outside to cancel this thing? Not really. Okay, I could do a little bit, but here's some of the machinations that we have to deal with. Okay, we have 1 plus u squared inside of a square root. This is shaping up to be kind of awful. Dx. And then we have our du is equal, and then we have our next piece here. We have du over e to the x. Uh, okay. So we could say something like this is 1 plus u squared over u du, and maybe we could try to figure out something like that. But now we have square roots and things that aren't squared. And this is not looking like it's going in any place that's kind of helpful. Okay, so um, I'm going to hold this as a thought, but maybe there's another U we could have picked. Okay, let's try. Like, let's again. We'll put a pin in this one. So why don't we say, how about we try U is equal to 1 plus e to the 2x. Okay, let's try that. Okay, that'll get the whole square root out of the way, and then we can deal with it that way. My du is going to be, this is 0, 2e to the 2x dx. Right? You might say, well, that looks like I'm going in the wrong direction. Like, maybe. But when I've got this piece right here, actually, we're not quite there yet. That's again, this is going to be kind of a mess because my du, I don't have a e to the 2x anywhere to kind of fix with this thing. This is just going to make it more and more of a mess. Um, I like this one. I like this one even less. Again, we'll come back to this if we have to, but this is definitely a second tier kind of a thing. I don't like this one at all. Let's see. What else do my choices here? We tried u, we tried the whole thing. I know. Why don't we take the whole thing, even the square root? So why don't we set u to be the square root of 1 plus e to the 2x? Okay. Now, here's a very typical kind of a thing that people deal with is they don't want to take du with the square root in there. I don't blame them. This is really messy and it tends to be kind of awful. So a very common trick when you have these square roots is you're going to say u squared is equal to 1 plus e to the 2x. Now, we're going to do implicit differentiation. Remember, we taught you guys that. So we're going to have 2u du equals, and then we'll go ahead and take this derivative, and we've got 2e to the 2x, right? Derivative of 1 is a constant, taking the chain rule on this one. So we've got something like that going on here. Okay, so that's my next little thought about this one. Like, okay, well, at least I've got a little bit of something here. We could think about something like that. So we have u is equal to this. We've got du. Okay. So let's see here. Why don't we go ahead and say here we're going to say u squared minus 1 is equal to e to the 2x. I'm like, why are you doing that? Like, well, because I got an e to the 2x sitting here, and I don't know what to do with it. Why don't we divide both sides by 2? Divide both sides by 2. So we have u du equals e to the 2x dx. Okay? So here we have our e to the 2x. Why don't we say that that's u squared minus 1? So now I have u over u squared minus 1 du is equal to dx. This is promising. I know it looks like that does not look promising to anybody except maybe you. But trust me, this is promising. You have to do a couple of these problems where the U's are kind of a little bit in a knot that you have to untangle, which is inside of something else that you have to untangle, and eventually you actually do get to untangle this thing. So as I am going back up and looking at my original problem here, okay, we have S, remember, I'll just remind us what's going on here. So we have S equals the square root of 1 plus f prime of x squared, okay, dx. And that's what we're going to try to integrate here. So if you remember, what the heck was 1 plus f prime of x? Well, square. That was going to be u. So this whole piece here, this is just going to be u. Now, so I'm substituting this whole piece in for you. What was my du? Well, du is u over u squared minus 1. We try and integrate this piece here. We still have our x limits, x equals 0, x equals 1. So we could change our limits of integration at this point, and trust me, that is looking more and more and more attractive. But we're going to hang on to just our x's for a little while longer, which this is going to turn into my x is equal to 0 to x is equal to 1 of u squared over u squared minus 1. Oh, this looks like a partial fractions problem. Well, almost, except for, this is the reason why I wanted to show you this problem. The other reason I wanted to show you this problem is that notice that the degree on the top is the degree on the bottom. We can't do partial fractions with that yet. We have to put it in the right form. So let me show you a little bit of a trick before you have to do the polynomial division. We're going to say we have u squared over u squared minus 1. We still have our integral going from x equals 0 to x equals 1. And what I'm going to do is I'm going to subtract 1 over u squared minus 1, but I'm going to add 1 over u squared minus 1. See, if I put these together, I just added 0. Okay? The astute student will say, oh, you added 0 with this. I've never been the astute student, but this is a way to do this. So what's going to happen with this first term is that we're going to get the integral of 1 plus 1 over u squared minus 1 du. Now I can do partial fractions. This isn't too bad of a partial fractions problem to do. We have 1 over u minus 1, u plus 1, and we're going to say that that's equal to a over u minus 1 plus b over u plus 1, and we'll go ahead and sort out what's going to happen here. We clear the fractions. That's the first thing we're going to do. So we're going to have this as a u plus 1 plus b u minus 1 is equal to 1. Okay, and then we can go ahead and equate our coefficients. So we're going to have the u parts of this thing. Okay, I'll go ahead and write down a u here. So we have a plus b is equal to 0. And then we're going to have a minus b is equal to 1. Oh, I mean, as far as systems of equations go, I don't think I could have asked for a nicer one. So if we just add these two together, we have 2a is equal to 1. Oh, a must be 1/2. Well, if a is 1/2, b must be negative 1/2, right? Because we're going to go back to our first equation now. So here we go. We've got, where were we? We were dealing with the integral. So you see these can get a little bit long. So we have the integral of 1 plus 1/2, and I'm going to go ahead and pull the 1/2 out in front because I don't like to deal with the 1/2s and the numerators like that. And we are looking at 1/2. What was my a? My a was, what are we looking at here? Over u minus 1. Okay. Okay. And then we had a minus 1/2, and then we have, oh, we didn't, and then we had 1 over u plus 1. And this is all du. Now we integrate. Again, x was equal to 0, x was equal to 1. Now we can go ahead and integrate. Okay, hooray, we've integrated now. So we have u plus 1/2 natural log of u minus 1. I'm going to go ahead and say, since I know my x's are going to be all positive, that this is going, well, we'll go ahead. We'll wait on that for a moment. minus 1/2 natural log of u plus 1. This one certainly doesn't need the absolute values in there, but we'll hang on to it for a moment. So I'll show you one more little trick. Notice both of these have a 1/2. So here we have u plus 1/2 parentheses ln of u minus 1 minus ln of u plus 1. Do you remember your rules of logarithms? I'll bet you do. I'll bet you need to be reminded. So remember, we have the natural log of a minus the natural log of b, that was equal to the natural log of a over b. Sure you do. And we're going to do that exactly what we have right here. So we have natural log of one thing minus natural log of another thing. We're going to squeeze those together and just make one little piece out of it. You don't have to do that. It's just more aesthetically pleasing. So I've got my u plus 1/2 natural log of, here we have u minus 1, u plus 1, going from x equals 0 to x equals 1. Okay, remember all of that. All right, so there we go with all of those things. What the heck was u? Going way back up there. And I'm going to say recall. Okay, u was equal to, let's see here, if I can find my little pages here. U was equal to the square root of 1 plus e to the 2x. This is why you wanted to do a change. You wanted to change the limits of integration from x's to the u world and make it do it that way instead. It's not nice, but it's a little bit nicer. Okay. So we can go back and we can say what's going to happen with that. So we're going to say this is the square root of 1 plus e to the 2x plus 1/2 natural log of, oh, this huge. So we have the square root of 1 plus e to the 2x minus 1. This is going to be a number that's bigger than 0, so I can get rid of my absolute values here. And then here we have the square root of 1 plus e to the 2x plus 1. And then we're going from x equals 0 to x equals 1, right? Piece of cake. Now we just have a giant calculator extravaganza here. So what we're going to do, this is always the hardest part of the problem. It really is. X equals 1. Let's go ahead and plug that in. So we have the square root of 1 plus e squared, okay? Plus 1/2 natural log. I've got x equals 1 here. So this is the square root of 1 plus e squared, okay? Minus 1 over square root 1 plus e squared plus 1. All right, so that's that little part there. Now, I'm going to plug in 0. Remember what e to the 0 is? E to the 0 is 1. So if I plug in 0 here, we have 1 plus 1. So that's going to be a square root of 2 sitting here. Okay, and then we're subtracting this whole thing. So minus 1/2, and I'm plugging in 0 here. So we have the square root of 1 plus 1. So we have the square, so we have natural log of 2 minus 1 over square root of 2 plus 1. And that there is our whole pieces, okay? Put a pin under this one for just a moment. You don't need to put a numerical answer into this. It's great if you can, but we're not going to worry about that. And I'll put one in here for a moment for you in just a moment. So what I'm going to do is I'm going to go ahead and shrink my little thing here. And I'm going to say, Desmos is truly magical, okay? So what I did was I just took my piece here, my arc length, integrate from 0 to 1, the square root of 1 plus 2x dx, and I just got an answer here, 2.003 plus some other stuff. And then what I did was I took my calculator and I said, what was going to be all this stuff here? So if we have all of these pieces here, we have all of this stuff going on here. And we can say, oh, look at that. The square root of 2 there, minus 1/2 all of this stuff. Same thing that I just got. Hey, look, the answers match. I'm pretty happy that I think I got the right answer out of this one. So that's what I'm going to do for showing you guys how to use Desmos to kind of verify your answer. You didn't have to go through all this pesky integration by hand, but Desmos is, you can't put that in a product that you've made and then say, well, just see Desmos. They're like, no, 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 no. This is for you to do because at some point you're not going to want to make calls out to Desmos to get your program to work so that you can sell your program or your company can sell your that program to something that's really nice and you guys can make money doing it that way. But if you got to say, well, I'm leaning on Desmos, I'm like, well, I'm sorry, Desmos is open source. You're not allowed to make money off of that. So there's a reason why you would want to be able to do this stuff by hand. And here it is. You also need to pass your test. Okay. So I wanted to show you that one because it's got this horrible use substitution pickle that you've got to go deal with. It's got a kind of a clever partial fractions thing that you got to go deal with. And then numerically, this thing is just a mess. So I hope that helps a little bit. I probably wouldn't put one like this exactly on your test, but you never know. So one of those things, like at least you've now seen like the path for doing it, and you like can pick a little bit of a better you. You won't just say, well, let me pick that one and see what happens. Okay. So that's how I did this problem. I'm going to say thank you very much for watching the video. I'll see you in the next one and take care until then.